sources say the airplane's speed upon approach appeared to be excessive.
The plane was at the center of an army of emergency workers, and there was a parade of ambulances between the airport and local hospitals.
The center portion of the fuselage was completely engulfed in flames.
Emergency crews are still working at the crash site, and we expect to get
Each time you approach a runway, the risks associated with an approach and landing accident are present. It's during this phase of flight operations where the greatest number of accidents occur. The risks include the non-stabilized approach, landing short, landing off the side or off the end of the runway, and controlled flight into terrain. How close have you come? Would you make the timely decision? Have you been trained to recognize and avoid these risks? Do you realize that it can happen to you? During the 1990s, extensive industry attention was focused on CFIT, controlled flight into terrain, because it was the single biggest risk to aircraft crews and passengers. The industry continues to focus on CFIT. However, this video focuses on ALAs, approach and landing accidents, because no matter what type of airplane you fly, or whether you fly for an airline, a corporation, or a private operator, approach and landing phase accidents now cause the largest number of hull losses. While flight crews are unaware that a CFIT encounter is developing, approach and landing accidents differ in that many of the risk factors can be recognized by the crew well before an event threatens safety. Awareness means that crew action can be taken to avoid the potential approach and landing accident if the crew recognizes and acts upon the risks as they are developing during the approach. The Flight Safety Foundation's Approach and Landing Accident Reduction Task Force has gathered extensive data on ALA incidents. Analysis of this data points to several leading ALA causal factors.
Speed's creeping up faster, 15 knots fast. Coming to 500 feet.
500.
2 dots high.
Well, approach is unstable. Go around.
Going around.
These factors include not being stabilized on approach, not following established procedures, lack of vertical position awareness, and most critically, failure to go around. Think about it. You've most likely found yourself in one or more of these situations many times during your flight career. You've often been able to work through the situation, but each approach and landing is unique, and each presents the possibility that one or more of the causal factors may negatively impact the approach, as was the case for numerous crews in previous accidents. The Flight Safety Foundation's Approach and Landing Accident Reduction effort incorporates the views of more than 300 industry experts from airlines, government agencies, business aviation companies, and aircraft manufacturers. A major part of this effort is to provide you with strategies and tools that enhance your awareness of the risk factors you are likely to encounter during approach and landing. The solutions and tools that follow should be used to guide your actions, but you must recognize the risk factors, then take appropriate action. One way to avoid an approach and landing accident is to make the decision to go around. Everyone, the flight crew, management, and air traffic control must recognize that it is okay for the pilot to make the decision to go around. Approach and landing accident research clearly shows that in cases where a go-around decision would have been more appropriate and might have prevented an accident, 87% of the flight crews chose not to go around. Furthermore, some accidents occurred because crews were not prompt and aggressive in responding to GPWS warnings and low-altitude go-around situations. A key factor in making the go-around decision is to constantly reassess your decision to land during the approach. Note that there is a time when it is no longer appropriate to go around. For example, when spoilers and thrust reversers have been deployed. Your operational procedures should have appropriate information regarding these situations, and you should follow those procedures. So, when is it appropriate to go around? To begin with, if your approach does not meet the stabilized approach parameters we are about to discuss, you should always go around. The following parameters recommended by the Flight Safety Foundation define a stabilized approach and should be met by 1,000 feet above touchdown in IMC conditions. The aircraft is on the correct flight path. Only small changes in heading and pitch are required to maintain the flight path. The aircraft's speed is not more than VREF plus 20 knots indicated airspeed and not less than VREF. Sink rate is no more than 1,000 feet per minute. The aircraft is in proper approach and landing configuration. Power setting is no lower than the minimum specified for the type of aircraft, and all briefings and checklists have been performed. All of these approach parameters must be met by 500 feet, including visual approaches. If your standard operating procedures do not include parameters for a stabilized approach, the Flight Safety Foundation recommends that you use the parameters just listed. In a situation where you are unsure of your position, such as an unexpected radio altimeter reading, a go-around should be called for. Always check altitude against range. You should not see radar altitudes less than 1,000 feet while on an instrument approach prior to the initial fix. And you should never see radar altitudes of less than 500 feet between the initial fix and the final approach fix. You should never see less than 250 feet past the final approach fix, unless you are on an approach with lower minimums or until going visual. Pre-planning in your approach briefing will allow you to make a timely go-around decision when weather is having a significant impact, such as loss of visual reference, or when the presence of significant crosswind, headwind, tailwind, or wind shear come into play. In most approach and landing accidents, deviation from standard operating procedures was a leading causal factor. Your procedures have been developed and proven in order to assist and protect you, and you must use them. Decades of experience stand behind every standard operating procedure. Think of SOPs as a series of rules that, if followed, prevent incidents and accidents that have occurred in the past. A number of standard operating procedures deal specifically with approach and landing. Among them, as previously discussed, the elements of a stabilized approach, the use of the radio altimeter to assist in altitude awareness, involvement of all crew members where required by procedures, during the approach briefing and cross-check, for example, use of the ground proximity warning system, and the go-around decision. Standard operating procedures do need to be periodically reviewed. As a flight crew member, you have a responsibility to call attention to those procedures you feel need to be changed. Take ownership of the procedures that your company uses. They are your procedures as well, and require routine and critical evaluation to determine the need for change. One key standard operating procedure is the approach briefing. All crew members must understand what is planned for on the approach and must be involved during the discussion of the plan. Both horizontal and vertical position awareness elements need to be established. The Flight Safety Foundation recommends that in addition to the standard briefing items such as chart date, runway in use, approach type, glide slope angle, and crossing altitudes, the following items should be briefed as appropriate: automation setup and usage, navigation equipment setup and monitoring, rate and angle of descent, intermediate altitudes and callouts, altitude alert settings and acknowledgments, approach gates, timing, runway environment, lighting, expectations when going visual to include offsets, radio altimeter usage, and awareness, and a discussion of possible risk factors, including conditions that will dictate a go-around.
Okay, in the event of a missed approach, we'll climb straight ahead to 1,800 feet, climbing right turn to 4,000.
A number of specific items must be a part of the approach briefing. As previously reviewed, the crew must discuss, plan, and prepare for the possibility of a go-around. The briefing should include a discussion of the use of all available navigation and approach aids appropriate to the approach being flown. A discussion of the use of the radio altimeter should also be a part of the briefing. To avoid confusion, the discussion should include the use of automation on the approach, as well as the circumstances when the use of automation will be discontinued.
Autopilot disengage.
Discuss the possible risks associated with the approach. These include, but are not limited to, terrain, non-precision approach aids, short runway, and current or unexpected changes in weather conditions. To assist this discussion, the Flight Safety Foundation has developed a risk assessment tool that can be used to raise your awareness of the possible risk factors. Weather and runway conditions are two areas which can compound the risks during landing. For example, increased risk is involved with a short runway or a wet or icy runway. Wind or partial obscuration of the runway are also risk factors. A combination of any of these factors increases risk further. All flight crews must consider and discuss the effects of these types of risks that might be present on the approach and landing, and how they might influence the landing itself and the airplane's ability to stop. Make preparations and decisions early. Remember that it's okay to say no to air traffic control when you cannot safely comply with their request.
It looks like air traffic is landing on both runways, 32 right and runway 22. The wind is 280 degrees at 25 knots. Both runways are dry. So if ATC offers us an option to land on runway 22, we won't accept it. We'll stick with the runway 32 right as we discussed because it's a better runway. Any questions?
Plan on a safe arrival before an on-time arrival. Know where you are vertically. You are responsible. Be aware and discuss minimum safe altitude, area terrain, terrain clearance, and altitude corrections if abnormally low temperature is a factor. In short, use the approach briefing to thoroughly discuss the approach and the use of all available resources. As just mentioned, vertical situational awareness is your responsibility. If the ground proximity warning system alert sounds, you must be prepared to execute an immediate pull-up. Except in clear daylight visual conditions, the flight crew should immediately and without hesitating to evaluate the warning, execute the pull-up action recommended in their company's procedure manual. Remember that the need to pull up or go around may occur for reasons other than terrain, such as an unstabilized approach, a high sink rate, improper configuration, or deteriorating environmental conditions. It can also be driven by an unintentional error on the part of a controller, or with the approach procedure design, or other factors. In other words, you may be doing everything right from your point of view, but you may still get a pull-up warning. It must not be ignored. Early generation GPWS sometimes gave false warnings, and some flight crews became accustomed to ignoring the warnings, leading to numerous CFIT accidents. Today, GPWS is extremely reliable due to enhancements in technology, and advanced systems such as the enhanced GPWS and the Terrain Awareness Warning System are even better. False warnings are highly unlikely with these new systems. The Flight Safety Foundation supports installation and usage of the newest technologies, such as EGPWS, and recommends that your fleet be updated to this type of equipment. As a pilot, you should ensure your operations are conducted with the most current version of the software for the system you are using. GPWS is designed to assist you by giving you warnings. Cautions given by the system require you to adjust the flight path,
Glide slope. Glide slope.
glide slope, and bank angle, for example. For extreme conditions, these systems give warnings that you must react to immediately, such as
Pull up. Pull up. Pull up. Sink rate. Sink rate. Sink rate. Sink rate.
when warnings do sound, the pilot not flying must be involved and assist the pilot flying.
We're not stabilized. Shouldn't we go around?
Go around.
When it comes to approach and landing safety, it's the simple back to basics that will certainly keep you out of trouble. The determination to immediately and unequivocally pull up when given a GPWS warning. The use of standard operating procedures and an approach briefing plan for every approach and landing. And finally, the mindset that it's okay to go around. These may seem like obvious procedures and strategies. However, approach and landing accident data clearly show that over and over again, lack of attention to these basics were the dominant factors leading to approach and landing accidents. Don't end up next on this list. What are you doing to prevent that from happening? Remember that it can happen to you. You will find yourself in similar situations. Think about it. Have you reviewed your operational procedures recently? Are you properly trained? And will you make the go-around decision?